So we're given a functional equation. The derivative of the inverse of f of 6x is equal to x squared, and f of 3 cubed is 10. What is f of x? And we have this important rule right here, which is that derivative of the inverse of x is 1 divided by the f prime of f negative 1 of x. And using that, we can quickly rewrite what we have right here as 1 divided by f prime of f negative 1 of 6x. And this is going to be equal to x squared. And we can take reciprocals of both sides, and we get the f prime of f negative 1 of 6x. It's going to be equal to 1 over x squared. And now what we can do is we're going to make a substitution. We're going to let u equal to f negative 1 of 6x, which in turn means that f of u is going to be equal to 6x. And this fu was not on purpose. Apologies. What we can do is now we can sub in our u. So we get that f prime of u equals 1 over x squared. And now what we want to do is we want to express x in terms of u as well. And we have this right here, which will help us do that. So we can go ahead and isolate x here, and we get that x is going to be equal to f of u divided by 6. And we can sub that in, and we get that f prime of u is going to be equal to 1 divided by f squared of u divided by 6 squared, which is 36. And now we have a differential equation. Now, what we're going to do is we're going to go ahead and do another substitution just to keep things clean. Let a be equal to f of u. And so now we can rewrite this like this. dA du is going to be equal to 36, bring that up to the top, 36 divided by f of u squared, which, keep in mind, that's just a squared, divided by a squared. And then we get dA over du times a squared equals 36. Now we can bring du over to this side, and we get that a squared dA is equal to 36 du. And now what we can go ahead and do is we can integrate both sides. So integral of a squared with respect to a is going to be equal to the integral of 36 with respect to u, which is going to be equal to a cubed divided by 3 plus our constant c, 1. And then we're going to have this be equal to 36u plus our second constant. But since these are just arbitrary constants, we can go ahead and subtract c1 from both sides and just make it as c3, or we'll just call it c. So we get a cubed over 3 is going to be equal to 36u plus c. Right. So, now remember that our a is equal to our f of u. So now what we can do is we can multiply, well, first replace a with f of u, then multiply both sides by 3, and we get 108 plus 3c, but we can just call it c again. It's an arbitrary constant, it doesn't really matter. And now we can cube root both sides of the equation, and we get that f of u is going to be equal to the cube root of 108u plus arbitrary constant. And at this point, u has no significance here. It's just the input of the function. So what we can do is we can just sub that in with f of x. And this is going to be equal to cube root of 108x plus c. And now we'll use our initial condition that f of 3 cubed equals 10. So what we can do is we can plug in our 3 of 3, which is going to be equal to this thing right here with a 3 plugged in, which is going to be the same thing as 324. And we're also cubing it. So we're going to cube this. It'll get rid of the cube root. And we get the f of 3 cubed is equal to 324 x, or 324, plus our constant c, which is going to be equal to 10. So now we can subtract 324 from both sides, and we get that c is equal to negative 314. And we can plug this back into our function that we have, f of x, and we get that f of x is going to be equal to the cube root of 108x minus 314. And yes, that is intentionally the first digits of pi.